Imagine if you could revisit the past or leap into the future. Sounds like science fiction, right? We've all been captivated by the idea of time travel, whether it's Marty McFly zipping back to the 50s, or the Doctor whisking companions across the cosmos. It's a concept that has permeated our culture, from literature to blockbuster films. But what if it isn't just fiction? What if science could provide some answers? Let's embark on a journey through time to find out. The concept of time travel is not a modern invention. Its roots trace back to ancient times when people fantasized about voyaging to different eras. But the scientific theories around it gained traction in the late 19th century. One of the early thinkers who made a significant contribution to time travel theories was H.G. Wells. His seminal work, The Time Machine, published in 1895, introduced the concept of a machine that could carry an individual through time. Although this was science fiction, it sparked a cultural fascination with the idea that has persisted to this day. Wells wasn't alone in his fascination. Other notable contributors include the mathematician Kurt Gödel. In the early 20th century, Gödel proposed a solution to Einstein's equations of general relativity that allowed for the possibility of time loops, effectively paving the way for the theoretical possibility of time travel. Even before Gödel, the Irish physicist George Francis Fitzgerald and Dutch physicist Hendrik Lorentz came up with the Fitzgerald-Lorentz contraction in 1889. This concept, later incorporated into Einstein's theory of relativity, proposed that a moving object appears contracted in the direction of its motion, a key idea that would later influence theories of time dilation. These early theories laid the groundwork for more sophisticated ideas about time travel. They were the stepping stones that allowed us to entertain the possibility of hopping between different points in time, a concept that continues to captivate our imaginations today. Enter Albert Einstein, who revolutionized our understanding of time. In the early 20th century, this brilliant physicist introduced a radical concept that shook the very foundation of physics. Einstein's theory of relativity turned the notion of absolute time and space on its head, proposing that time and space are interconnected in a four-dimensional fabric known as spacetime. Einstein's theory is composed of two parts: special relativity and general relativity. Special relativity postulates that the laws of physics are the same in all inertial frames, and that the speed of light in a vacuum is constant, regardless of the motion of the source or the observer. This implies that time can slow down or speed up, depending on how fast you're moving relative to something else. This is known as time dilation, a concept we'll delve deeper into later. General relativity, on the other hand, is where gravity enters the picture. It proposes that massive objects cause a distortion in spacetime, which we perceive as gravity. A well-known analogy is to imagine spacetime as a trampoline and a massive object, like a bowling ball, placed in the middle. The ball will cause a dip in the trampoline, causing any smaller objects to move towards it. This is similar to how planets orbit around the sun. But what does all this have to do with time travel? Well, if time and space are interwoven in this spacetime fabric, and if this fabric can be distorted, then it's theoretically possible to twist and fold spacetime in such a way to create a shortcut, a wormhole from one point to another. This could allow for faster-than-light travel, effectively making time travel possible. However, it's important to note that these are purely theoretical concepts. While Einstein's theories have been proven correct in many experiments, the existence of wormholes and the possibility of time travel remain speculative. They're exciting ideas that have sparked countless debates and inspired numerous science fiction stories, but we're still far from turning them into reality. Einstein's theory opened the door to the possibility that time travel could exist within the laws of physics. But as we'll see in the next scene, the journey through time is a complex one, filled with mind-bending concepts and paradoxes. One of the most interesting aspects of Einstein's theory is time dilation. Now, what is time dilation exactly? Well, it's the idea that time doesn't tick at the same rate for everyone everywhere. Think about it this way. Have you ever heard the phrase, "time flies when you're having fun"? That's a subjective experience of time moving faster. But with time dilation, that difference in the passage of time is not subjective. It's real and measurable. Consider two clocks. One is stationary on Earth, and the other is on a spaceship zooming close to the speed of light. According to Einstein's theory of relativity, the clock on the spaceship would tick slower compared to the clock on Earth. This is time dilation in action. In fact, we have proven this with precise atomic clocks. One was kept on Earth, and another was sent on a high-speed flight. When the flying clock returned, it had indeed ticked fewer times than the one that stayed put. This experiment showed us that high speeds can slow down time. Now, you might be wondering, why does this happen? The answer lies in the fabric of space and time itself. When you travel at high speeds, or when you're near a massive object, the fabric of space-time warps, and this warping affects how time flows. Time dilation shows us that time is not a constant, but can be manipulated. This mind-bending concept challenges our everyday experience and opens up fascinating possibilities for the future. Einstein didn't stop at time dilation. He also predicted a link between gravity and time. So what does this mean? Well, let's dive into it. Einstein proposed that gravity isn't just a force that pulls objects towards each other, it actually warps the fabric of space-time itself. Picture this, space-time as a stretchy sheet. When something heavy, like a planet, is placed on it, the sheet bends around that object. This is Einstein's vision of gravity, not a force pulling objects, but a curvature of space-time causing objects to move on a curved path. But where does time come into play? Well, Einstein suggested that the stronger the gravity, the slower time passes. This is known as gravitational time dilation. It's a mind-bending concept, but let me break it down. Imagine two clocks, one at the top of a mountain and the other at sea level. According to Einstein's theory, the clock at sea level, which is closer to the Earth's center and thus experiences stronger gravity, would tick slower than the one at the top of the mountain. And guess what? This isn't just theoretical, it's been tested and proven. Atomic clocks at different altitudes have shown differences in timekeeping, with those closer to the Earth's surface lagging behind those at higher altitudes. Crazy, right? So, how does this relate to time travel? Well, if gravity can slow down time, then strong enough gravity might allow time to be manipulated to such an extent that we could travel through it. If we could create a gravitational field strong enough, we might be able to slow time down significantly, or even reverse it. Of course, the practicalities of creating such a field are currently beyond our technological capabilities. But the principles behind it, as outlandish as they might seem, are grounded in the science of Einstein's theory of relativity. This link between gravity and time further supports the idea of time travel. So while we might not be packing our bags for a trip to the Jurassic period or the far future just yet, the science suggests that one day it might just be possible. But there's a catch. Einstein also proposed a cosmic speed limit. This cosmic speed limit, as you might have guessed, is the speed of light. You see, according to Einstein's special theory of relativity, nothing can travel faster than light, which moves at a staggering 299,792 kilometers per second. Now, why does this matter for time travel? Well, as we approach the speed of light, time for us would slow down relative to someone who is stationary. This is known as time dilation. So, in theory, if we could somehow reach the speed of light, time would stop completely. However, there's another catch. As we get faster and faster, our mass increases and it would require an infinite amount of energy to reach the speed of light. And currently, we don't have an energy source that infinite. So, while time travel might be possible, getting there is another story. But what if there were shortcuts through space-time? The cosmos, it seems, may have a few tricks up its cosmic sleeve. Enter wormholes, theoretical tunnels that could, in theory, serve as shortcuts through spacetime. Just as a tunnel through a mountain is a shortcut from one side to the other, a wormhole could potentially do the same, but on a cosmic scale. To understand wormholes, we need to delve a bit deeper into Einstein's theory of general relativity. This groundbreaking theory proposes that space and time are woven together into a four-dimensional fabric known as spacetime. Massive objects such as stars and planets warp this fabric, creating the curves we perceive as gravity. But Einstein's equations also allowed for the possibility of bridges in the fabric of spacetime. These bridges, or wormholes, could theoretically connect two distant points in the universe, drastically reducing the travel time between them. Sounds like a perfect shortcut, right? But there's a catch. In their natural state, wormholes are incredibly unstable. They would require something known as exotic matter to keep them open. This exotic matter, still purely theoretical, would possess negative energy density and large negative pressure, essentially defying our current understanding of physics. Yet, despite these challenges, the idea of wormholes continues to captivate scientists and sci-fi fans alike. If we could find a way to stabilize a wormhole, it could not only serve as a shortcut through space but also potentially through time. Imagine stepping into a wormhole and emerging not just in a different location, but in a different time. This could open up possibilities for time travel that are straight out of the realms of science fiction. You could potentially visit the dinosaurs in the morning and have lunch on a future Mars colony. Of course, these ideas are still very much in the realm of theory, but as we continue to push the boundaries of our understanding of the universe, who knows what we might discover. Wormholes could be the key to making time travel a reality. Time travel isn't without its complications. The complexities of venturing into the past or future extend beyond the realms of physics and science, plunging us into a labyrinth of paradoxes that challenge our understanding of reality. One of the most famous of these conundrums is the grandfather paradox. Imagine for a moment that you have a time machine. You decide to travel back in time and, for reasons best known to yourself, you accidentally cause your grandfather's demise before your parents' birth. If your grandfather is gone, your parent and subsequently you should never have existed. But if you don't exist, who traveled back in time and caused the unfortunate incident? This paradox creates an infinite loop that defies logic and disrupts the linear concept of time. Another head-scratcher is the bootstrap paradox, named after the phrase, pulling yourself up by your bootstraps. In this scenario, imagine you're a scientist in the future who invents a groundbreaking piece of technology. You decide to take your invention back in time and give it to your younger self, who then becomes famous for inventing it. The question then arises, who really invented the technology? If the invention was simply passed from the future to the past, its origin becomes a mystery, creating a time loop with no clear beginning or end. These paradoxes pose significant challenges to the concept of time travel. They highlight the potential for time travel to disrupt the natural flow of events and create logical inconsistencies. They also underscore the need for a better understanding of the nature of time itself. Time travel is not just about moving from point A to point B in time, it's about understanding the fundamental laws that govern our universe, and how we, as temporal beings, fit into this grand cosmic puzzle. So, while we dream of hopping into a DeLorean or stepping into a TARDIS, we must also confront the realities and potential dangers that time travel poses. These paradoxes remind us that time travel isn't as simple as flipping a switch or turning a dial. It's a complex and intricate dance with time, a dance that we are still learning the steps to. These paradoxes pose significant challenges to the concept of time travel. Enter the world of quantum mechanics. This realm of physics is a world where things can exist in multiple states at once, only revealing a definite state when observed. This is the intriguing concept of superposition. But how does it tie into time travel, you ask? Well, let's consider a time traveler who wants to change the past. In the classical view, this leads to paradoxes. For instance, what if the time traveler prevents their own birth? In the quantum world, however, there's a possible solution. Here we introduce the many worlds interpretation. Proposed by physicist Hugh Everett in the late 1950s, this interpretation suggests that with every decision or event, the universe splits into different versions, each version representing a different outcome of that event. So, when our time traveler changes the past, they're not altering their original timeline. Instead, they're creating a new branch of reality where the change took place. This neatly sidesteps the paradoxes as the original timeline remains intact. But, it's important to note, this interpretation is not universally accepted. Some scientists find it too extravagant, preferring interpretations that don't involve countless splitting universes. Yet it remains a fascinating possibility, a testament to the strange and wonderful world of quantum mechanics. In this light, time travel becomes more than just a journey through time. It becomes a journey through an endless forest of realities, each branching off into another, each with its own past and future. Quantum mechanics adds another layer of complexity to our understanding of time travel. So, where does this leave us? Well, the world of time travel theories is a bustling hub of scientific thoughts and debates. In the current landscape, researchers are delving deeper into quantum mechanics and the theory of relativity to better understand the possibilities and constraints of time travel. Particle physics, wormholes, and quantum entanglement are some of the exciting areas where scientists are pushing boundaries. Theoretical physicists are grappling with the complexities of space-time, trying to crack the code that could potentially unlock the ability to time travel. At the same time, they're also wrestling with paradoxes that seem to suggest time travel could result in inconsistencies within the timeline. In essence, they're trying to balance the mathematical possibilities with the physical realities, and it's no easy task. Emerging technologies such as quantum computers, could potentially provide new pathways and tools for these explorations. The future of time travel theories is as exciting and mysterious as time travel itself. But should we even attempt time travel if it were possible? This question takes us into the realm of ethics. Time travel isn't just about bending the fabric of space-time, it's about navigating the complex web of moral implications. Imagine the power to rewrite history, to prevent tragedies, or to cause them. Would it be ethical to change the past, knowing that every action can drastically alter the present? These questions are not just philosophical, they're deeply personal, impacting every individual's life in unforeseeable ways. Moreover, time travel could potentially lead to exploitation. What if it falls into the wrong hands? The power to manipulate time could be used for nefarious purposes, leading to a dystopian future. And then, there's the question of responsibility. If you could travel back in time, would you have an obligation to right past wrongs? Or should history be left untouched, with its lessons intact? Time travel is not just a scientific question but a moral one as well. Now we turn the question over to you. Time travel, a concept that has intrigued humans for centuries. We've explored its theories, its possibilities, the paradoxes, and even the ethics. But what about you? What are your thoughts on time travel? Do you believe it's possible to leap through the years, to touch the past or future with your own hands? Or do you see it as pure science fiction, an idea best left to novels and movies? Perhaps you've thought about the paradoxes and arrived at your own unique solutions. Maybe you're intrigued by the concept of time dilation, or the potential of wormholes as shortcuts through space-time. Or you might be pondering the implications of the many worlds interpretation of quantum mechanics. Whatever your thoughts, we invite you to share them. Whether you're a seasoned physicist, an armchair scientist, or just someone with a curious mind, your ideas are welcome here. We can't wait to hear your thoughts on time travel. Time travel is a fascinating topic that continues to intrigue scientists and laypeople alike. We've journeyed through the birth of time travel theories, the role of Einstein's theory of relativity, and the intriguing concept of time dilation. We've explored the gravity time link, the cosmic speed limit, and shortcuts through space-time, not forgetting the paradoxes and quantum mechanics involved. We've considered the future of these theories, their ethical implications, and your own thoughts on the matter. Whether or not time travel is possible, it certainly makes for an engaging discussion. If you enjoyed this journey through time, give us a thumbs up. Don't forget to share this video with fellow science enthusiasts, and hit that subscribe button to stay updated with more mind-bending journeys into the world of science. And remember, the future is yet to be written. Thanks for watching. If you've enjoyed this exploration into time travel, you might also like our videos on quantum mechanics or the theory of relativity. Remember, science is always evolving and so is our understanding. See you in the next journey through the mysteries of science.